Alright, welcome everyone. This is the first episode of Useful Arduino Projects, where I go through some useful Arduino projects I have built and programmed to make my life better, funner, easier, all of that. So this is my latest creation. It is a air hockey table. Well, not really. I didn't actually create the table, I just created the scoreboard system and the program that actually keeps track of which player has scored which amount. This hockey table has several features, including two game types. A point to win, so you can set it so you can say if player 1 gets 25 points, they win, and if player 2 gets 10 points, they win, or you can set it to be both the same. And there's a time game. Now there's no real-time clock in this project. If you don't know what a real-time clock is, I'll be making a video later on, a part of our course. There's no real-time clock, so we're just using the built-in counter, and I found it's perfectly fine to count down. You can set it for a maximum game time of 9 hours and 59 minutes, which is ridiculous, but when you go into the quick game, it's just a 5-minute game, and whoever gets the most points at the end wins, and if they get the same, it's a tie, obviously. There's also some really cool features with this board that I think are actually rather useful, including you can save custom player names. So how you do that is in the program, we'll look at that later. It has a bunch of define and then strings, and you can save, I think it's about 12 players, up to 12 players, and you can select them for a quick player game. There is also a feature where you can enter a custom name using the 5 buttons here in order to create a new player name for player 1 or player 2. This program makes use of the Arduino's EEPROM also by saving score values, because how each score box works is there's an LED in both of them, which is white, and then there's a light sensing resistor. This resistor reads how bright the LED is per se, and usually it's around 15 on the ADC value, which is analog 1 and analog 2, etc. And basically, when the puck, which is this, goes through the score box, it blocks that light. It can be really quick, but the analog pin will actually sense that, and it will say, alright, here's a point. The problem is, however, sometimes in differently lit environments, especially if the light is over here and shooting into here, obviously that resistor is going to read a little bit more light. So you can actually go into the settings and change what I like to call the score value, which is where if it drops below that value, then that's the score. Again, we'll look at that in the program, so don't stress that about now. There's also a little beeper, which is a little... It's rather annoying, but it just tells you when you've scored and etc, etc. I've also gone ahead and 3D printed the mount for this, which is 2 parts, so you can have it straight like that, or you can put the adapter and have it curved. I much prefer it curved, and probably should have just made one model with it curved, but I didn't. There's also a little switch box right behind me, which you'll be able to see on the screen. It's got a switch and a 12-volt input for a barrel jack. The Arduino board in here was soldered by myself with a perf board, and it fits well, but if you've tried to make custom Arduino shields, you'll know that some of the pins don't properly align. So it's a little bit of a harsh fit. There's a relay on here which activates the fan, which blows the air above here and allows the puck to move. Now, I got this hockey table a long time ago for a great deal, and then it's been sitting in storage for ages, so it has coffee stains on it and it's rather ugly. The scoreboard it came with, which I took apart trying to get an idea of how it read the scores, but the original scoreboard was much smaller and it made use of a 7-segment display, only one for each side, so you could only score up to 10 points. In fact, when you got to 10 points, you won. The problem with that scoreboard, there were plenty. Sometimes when you hit the puck, it gets stuck. Right? That rhymes. And when it gets stuck, on the old scoreboard, it just kept scoring one player until they won. This scoreboard, it has a while loop so that it senses while this puck is in there, it'll pause the game. And not only that, you can actually take points off a player if it accidentally gives the player another point. The menu system is rather simple, however could be much better, as a lot of the program is, because I wrote this program just for a bit of fun, really, to get this actually working. I didn't write it for an actual production run, so it's not like this is going to be used all around the world and it had to be perfect. So there are a lot of errors, and we'll look at that in the code, and I'll explain where there are some errors and how you can fix them. However, I'm probably not going to fix much of my code because it works, and that's all I needed to do. So we'll go ahead and switch the switch on, and you'll hear the fan ramp up, and it'll turn off, but that's while the Arduino is initializing and the relay is still on. So you can actually hear the relay click. And then it takes you to the menu system. One thing that I wanted to implement was this ribbon cable for this LCD and buttons, so that you can actually pick it up and enter your custom name or do anything with it. Now this LCD I did not make, obviously. It's got acrylic, and this was off an old 3D printer of mine, a ANET E2. So it has buttons with resistors, so it's a single analog pin to read all 5 buttons. We'll look at how I implemented that. Again, that could be done better because sometimes the buttons get confused with each other. There was one free pin on the 10-pin connector, which I used for the beeper. Alright, let's go ahead, go upstairs, take a look at some of the code. Right, so we're back in the office now, and I have the program open in front of me, as you can see. We're going to go ahead and run through pretty much each step of the program. As you can see, there is a lot to it. There are a lot of pages, there are a lot of voids. We'll just get right into it. So I made use of 2 libraries. The Liquid Crystal library, which utilizes the wire.h library, and the EEPROM library in order to actually write EEPROM values to the EEPROM. So first thing we're doing is we're defining our inputs. Alright, so you can see ADD1, which is 0, ADD2, which is 1, which stands for address 1 and address 2 for the EEPROM. We'll see that later. Goal 1, goal 2. We have up max and up min. This is for the resistor matrix buttons. So we can see when we press the up button, it'll give a reading or a value between 800 and 650. I've done this for all of the buttons, including down, left, right, center. And standalone is when it's above 900, there's no buttons being pressed. Int A1 is 0. That is the actual minimum threshold for the scores. So we have A1 min, A2 min. We have relay, which is on digital pin 6, the beeper, which is on digital pin 7, and here is where we can name our 12 custom names. So we have, as you can see, hashtag define saved, then we have a string, custom 1, custom 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now this is where we go ahead and set our pins for our LCD, which is a 20 by 4 LCD, meaning we can have up to 80 characters at once. So we've gone ahead and used pins 8, 9, 13, 12, 11, and 10. Now int score 1 is 0. That's actually the counter for how many times the puck has gone into the score box of unit 1 and unit 2. Int y2 char select stands for character selection, which is 0. We have int x is 0. Linear clear, which is just to clear a line. It's simple. User 1, user 2, we can change these values when you change your actual player. String select, select 1, so up to 16. Int h, which is hours, int m, which is minutes, float s, and float time. We'll see why that is later. Int gt, which is game type. 2 score 1 and 2 score 2 are the values that you have to reach in order to win the game. And Boolean speaker, you did see that in the menu. You can actually turn the speaker off by setting it to 0. But its default is 1. So first of all, we go into this setup, which is where we begin the LCD, which again is a 20 by 4, and we LCD.home, and then pin mode, button pin high, 2 is an input pull-up, 3 is an input pull-up, beeper is an output, relay is an output, serial.begin, and then we go to start. We navigate to the page display, and we can see void start. So this is where it goes. So first of all, it goes ahead and says, alright, A1 equals EEPROM.read address 1, as we've seen before. So it's actually going to read what's in that address and then put that as the A1 minimum. It does that for A2, and then it digital writes relay high. But when you go high, the fan turns off. When you pull it to low, the fan turns on. Score 1 is 0, score 2 is 0, char select is 0, x is 0. Now we go ahead and line clear. We go ahead and define some things again. Why? Because this is actually going to read this very many times. So when you finish a game and you want to clear all this, it reads it again to the start. Alright, and then we actually get to printing the home screen, which lcd.setCursor 50, and then we go ahead and lcd.print air hockey. Alright, and then we go ahead and lcd.print 11, program written by lcd.setCursor 12, lcd.print tide for vella-verney, because it was written by myself. This is while analog read A0, which again is the button matrix for the actual display. While that is above the minimum threshold, which is 900, it says press to start, right? Because you're not pressing any buttons, you don't want to start it. But as soon as you press any button, it goes below 900, and then it goes ahead and continues. So we have a 500 millisecond delay, and then we go to main. Main is right under it. So void main, A2 equals, it just goes ahead and gives these, the A1 min and A2 min again. lc.clear, y equals 0. Now, y in this case is used for the actual y axis of the display. We'll see that later. Now, this is a good example of where my program could be better. I've gone ahead and just said, alright, while constant in 8 equals constant in 8. It's always going to equal 8, so it's always going to be a while loop, unless you press another button and it goes to another void. A better way to do this would be with a for loop. So if we go ahead and just change this to for, and instead of all this, we just put 2 semicolons, like that. And that would essentially be the same thing, and it's just going to go ahead and run that over and over again until you call another void. While it is in this loop, lcd.setCursor 03, print settings. Now this is the actual menu system you saw in the video. So I'll go ahead and play that again for you. And now it goes ahead and lists all of this. And then it goes ahead and lcd.setCursor 18, y. This is where y comes in. Y is 0 and 18 is the x-axis. So it goes ahead and goes 18 characters across and then 0, which is the top line. And then it goes ahead and prints an asterisk. This is how you can select where you want to go and how you navigate the menu system. And then we go ahead and if analog read A0 is above or equal to up min and so that's just basically reading the entire value of analog 0, which is up. So when you go up and y cannot be equal to 0, it's going to go ahead and go y equals y negative 1. So it actually moves the cursor up, but it can't move it up when it's at 0 because it'll go down back to below. So I've gone ahead and just implemented and then y is not equal to 0. I know this is pretty hard to follow, especially if you're a beginner, but this program is something that I've written, and as you can see I just sort of went a bit spaghetti on it, just programmed it how I wanted to. And I didn't really intend for it to be read by anyone else. That's why it's a big mess, and it's even hard for me to properly decode it and explain it. However, it does make sense. And then it goes ahead and lcd.setCursor 18y, lcd.print, and then lcd.clear. Alright, and then it goes ahead and goes back. Else if down, and y is not equal to 3, because remember, on a 20 by 4 LCD display, it goes 0, which is the top line, 1, second line, 2, which is the third line, and then 3, which is the fourth line. Now you might say, why don't you just go 1, 2, 3, 4, but it changes a 1 to 0. Yeah. And then again, y cannot be equal to 3, otherwise it'll just go up to the top, which then it just goes ahead and go y plus 1, which brings the cursor down. Yeah. And it does all that again. And now this one is if analog read is right max, so and right min. So if you press the right button, now this is where it goes into a switch and a case function, whatever it's called. So we have a switch for y, and then if y is 0, gt game type equals 1, lc.clear, user 1 equals player 1, user 2 equals player 2, 2 score equals 10, 2 score 2 equals 10, and it goes to game screen. What it's doing there is it's initializing all of the variables you will see on the screen. So as we saw before, user 1 actually gets printed into the corners. That's where it goes. Alright? And then 2 score 1, so that's if player 1 gets 10, player 2 gets 10, they win. And then it goes to game screen. We'll go to game screen, the game screen page soon. It's just a big mess of a program though. Then it breaks. But now, case 1, so if y is equal to 1, it goes ahead and gives, and then it goes ahead and gives minutes 5. That's for the quick time game, so it just gives 5 minutes, go ahead and play. Game screen. And GT equals 2. That's important, because that's how you figure out which game type is selected. And then case 2, if y equals 2. Game type equals 3, lc.clear, and then it just goes to custom and name select. Alrighty, and then Case 3 doesn't have to initialize anything because that's settings. Alright, now this is game screen, right? So game screen is just below LCD.clear, y equals 1, while GT equals 3. This is where the GT is very important, right? Because we go, GT stands for game type. If case is 2, which means you've gone ahead and selected custom game from memory, GT will equal 3, and then GT equals 3 here. So it will go ahead and loop this, which goes ahead and initializes and does the little writing thing where it's player 1 versus player 2, right? So set game types as rules, set game type / rules. You can go ahead and select timed game, point game, saved game, all of that. Now again, please, this is a big mess of a program. If I really have to, I would write it better, cleaner. At the moment it's just all over the place. So if you press up, it goes ahead and gives Y. That's basically just, again, selecting which type of game you want, right? And then if it goes case 1, it takes you to timed game. If GT equals 1, player dis, which, yeah, is player display, and that's actually going. So as we can see, this is where we can change which player name you are by using strings user1, user2. So it goes ahead and delay 500 LCD.set cursor 00, which is in the top left corner. And then LCD.print user1, speaker, beeper, speaker. Now again, speaker is that boolean, right? And you can change the boolean. If boolean is 1, the speaker will be written to 1. If it is 0, the speaker will be 0 and not make a sound. That is how we can turn the speaker on and off. Delay 500, beeper low, and then it pretty much goes through all of that, which is, again, a lot to go over. Alrighty, and then it will go ahead and go from here right back up to where it came from, and then I've used a for loop to just write this, which is a little divider in the middle of the screen. And then it goes to update dis, which is update display, and G1. Alrighty, now let's go ahead and go to game types. So we have a timed game here, and then this just goes ahead and if S, which is seconds, is above 59, then S equals 0, M equals M plus 1, which is minutes, and then it does that for all of them. M is above 59, M equals 0, M equals, H equals hours plus 1. Yeah, it's, again, a pretty big mess. So we've got another selection here for the screen menu, another one, and another one. And yeah, there's a lot of code here, a lot and a lot and a lot. And in fact, it uses 69% of the Arduino's memory, which is what, 22,370 bytes. Yeah. Then we go to GT1, which is game type 1. So this is G1, which is game 1. Now we go ahead and while GT equals 1, relay low, that's turning the fan on, and then we go to check. I can't even begin to go over all of it because there is just simply too much. Like this page alone is 152. This one's yeah. Name select is the only one that I'll go over again because it's actually interesting. So name select took me a little while to actually figure out, and that's where you can actually select a custom name by using the up and down buttons, and it goes through the alphabet. Right, so name select, LCD.print select player 1 name while 1 equals 1. Again, a constant int could be fixed by a for loop, inevitable for loop with just the 2 semicolons. No worries. Delay 100 milliseconds, LCD.set cursor X and 0. Right? And then we can go ahead and go, if up max, it goes to char cell equals char cell plus 1, right? And then at the end of here, it goes to letter select. Now letter select is over here, which is a void, again. And now this is where char cell, which is character select, comes into handy, because char cell, if char cell is 0, it just prints a space. And then it goes ahead and says string select equals that. Case 1, A, B, C, D, E, F, G, it goes right down to the alphabet. And then it does user 2 letter select, which is pretty much the same thing, just for user 2. Right, and then that's how you can actually, it adds all the strings together, which is here. So string, pretty long and lengthy program. There's settings, which has some EEPROM functions. And again, I wrote all of this by myself, which was absolutely tiring. Yeah, so there's just a lot of code. So yeah, let's go ahead and take a look at the actual hardware of this project and get away from this spaghetti mess. Blah. So to design the 3D printed parts, I went ahead and used Fusion 360 with my Ender 3 3D printer. We can go ahead and go to here, we'll get to projects, and I think it's in hockey table somewhere. There's a lot of stuff here, yeah, hockey table. So there's not a whole lot of designs. This is just the switch case, which is where the switch and the actual female plug is. It's taking a little while to load. I did create a custom puck, didn't really work. These were supposed to be brackets to hold the Arduino in place, however I just screwed it in. These did not work really well. So yeah, this is the little switch box. It's got my name on it, I put my name on everything, yeah. And then I went ahead and just filled it with hot glue when it printed. You can go ahead and select here, this is what holds the actual LCD display. Yep, so as we can see, this goes on top of the little, of the actual thing, and if we go to bodies, we should be able to turn this one on. Which, that's the one that actually screws in, and that you saw. But then as you saw, it's too flat, so I printed this that just slots over it, and again, printed really well. And for the actual Arduino shield, I don't have a schematic for it, because it's not that complicated. I just have a smoothing capacitor. On the actual Arduino down there, I have a heatsink because it gets hot with the linear power regulator for the 12 volts. And I'll go ahead and get my actual Arduino, which is genuine. I was going to use an Arduino Nano, however I decided against it because they are annoying. There we go, it just sits like that on the Arduino. There's a capacitor, a relay, this is for the 12 volt input, there's some resistors which are pull down, pull up, I'm not sure. There's the actual header, which is where the sensors plug into with the LEDs. There's the LCD port. This is for the actual fan to plug in, which connects to the relay. And this is a double-sided perf board, so there's some solder joints and wires on the bottom. Fairly simple stuff for that. So I hope you enjoyed this segment of useful Arduino projects. I'm planning in the future to actually create an acrylic table with a laser cutter, which would be very interesting because as you saw, that table is fairly dirty and not the best for airflow, but yes, stick around. I don't know. 22 minutes, what?